Section 3.8 is on solving systems of equations using inverse matrices. The identity matrix is a square matrix that when multiplied by another matrix equals the original matrix. It's kind of like the number 1, and it's indicated by an uppercase printed I. So for example, the 2 by 2 identity matrix looks like this: 1, 0, 0, 1. A 3 by 3 identity matrix looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. And you can probably kind of see the pattern of the ones going diagonally this way and the rest filled in with zeros. It's kind of cool the way it works. So, if a matrix is multiplied by its inverse, then it equals the identity matrix. So if matrix A is multiplied by the inverse of matrix A, which is indicated by A looks like to the power of -1, but remember that often means inverse as well. So A times the inverse of A is equal to the identity matrix. It's kind of like saying little a times 1 over A is equal to 1. The inverse of matrix A, which might have elements A, B, C, and D, is actually this right here: 1 over A times D minus B times C times this rearrangement of the elements in the matrix. You can do that by hand, or it is possible to use a calculator. Now, this is really useful in solving systems of equations. You can take a system of equations like we have here, x plus 2y equals 9 and 3x minus 6y equals 3. You can rewrite it as a matrix equation. Basically take the elements on the left side of the equal sign, put them in a matrix, and then the elements on the right side of the equal sign, put those in a matrix as well. The other way you can write this is you take the coefficients of these numbers, so 1, 2, 3, and -6, put those in a matrix, multiply by the x and the y, and that's going to equal the numbers on the right of the equal sign. We call this the coefficient matrix because it contains the coefficients. We call this one in the middle here the variable matrix because it contains the variables x and y. And then we call the last matrix here a constant matrix because that contains the two numbers that it's equal to. Now we can use letters to indicate these. Like uppercase A is going to refer to the coefficient matrix, and uppercase X is going to refer to the variable matrix, and B refers to the constant matrix. Now, if we were to multiply both sides of this equation by the inverse of A, that is this little a to the -1 on both sides, remember we said on the previous page that any matrix times its inverse is equal to the identity matrix. And that's basically just like 1. So what this means is that the variable matrix is equal to the inverse of A times B. In other words, x and y are going to be equal to the inverse of A times whatever the constant matrix was. Let's take a look at an example. Oh, before we get to an example, here's how you do it on your calculator, and I'll show you how to do that. We're going to input matrices A and B, and then I'm going to call up matrix A and take the inverse of it, multiply it by matrix B, and that will give me the solution of the system. So let's do an example here. First thing I'm going to do is take my coefficients and put those into a matrix. So 4, -2, 6, and 9, that's my coefficient matrix. Multiply that by your variable matrix, which is x and y, and that's going to equal your constant matrix, which is 22 and -3. So I'm really just kind of breaking that system apart. So this is A, this is X, and this is B. And if you'll remember from the previous page, if I multiply both sides of this by the inverse of A, then X is equal to the inverse of A times B. So let's go ahead and put these into our calculator. I'm going to put the A matrix in my calculator and the B matrix in my calculator. So remember, we go to matrix, and my A is a 2 by 2, so I'm going to need to change what I have here. So I want to edit A. and make it a 2 by 2. And I'm going to put in 4, -2, 6, and 9. And let's go back and change matrix B. I'll go over and edit B. And matrix B has 2 rows and 1 column. And it had the numbers 22 and -3. So let's quit and go back to our main screen. And what I want to multiply is the inverse of matrix A. So let's call up matrix A. And inverse is this button right here. It'll put a little -1 there. That's not raised to the power of -1. That's actually the inverse. And then I will multiply that by matrix B. Let's go ahead and grab him. And when I hit enter, I get a 2 by 1 matrix, 2 rows and 1 column, 4, -3. So that means that the solution to this, x, is actually, is that right? -4 and 3? Let me check. Oh, 4 and -3. Sorry about that. -4 and -3. Okay, but the way I really want to write my answer, since originally I was solving a system of equations, I want to write my answer as an ordered pair. 4, -3. And that's your final solution. And that might seem to be a little bit of work because we already know how to solve these by graphing, substitution, or elimination. But if you have a system of 3 equations with 3 variables, it's very difficult to do that by hand. Let's try it using an inverse matrix. So let's create our coefficient matrix. Just pull the coefficients off of the variables. I'd like you to actually show this step, write this out. And in this case, I have variables x, y, and z. And I have 60, -12, and -52. So this is my A, this is my x, and this is my B. And remember, x is equal to the inverse of A times B. So let's go ahead and put these into the calculator. So I will need to change A and make it a 3 by 3 matrix and put in my numbers. Okay, there's matrix A, and then let's go and put in matrix B. Matrix B has 3 rows and 1 column. It has 60, -12, and -52. And I'm going to quit out of this. Let's call up matrix A. Take the inverse of that and multiply it by matrix B. And hit enter. And I have -8, 4, and -4. So matrix X, my variable matrix, is -8, 4, and -4, which that's not how I want to write my answer. I want to write my final answer as an ordered triple because it's actually 3, values, x, y, and z, and that's how we write it like that. And believe me, this is a lot easier than trying to solve one of these by hand.